What's up, guys? How you doing? Selfie mode. It is Friday. It's 3 p.m. We're gonna do another stream. I'm super excited about it. I had some fun intro music. That song always pumps me up. We're gonna do some more music in a second, but just thought I would say hello, face to the camera, and we're gonna do some programming. So before we get started, I want to tell you what I'm working on, and I also want to put on some good jams. So the jams are going to come from over here. Bam, boom. All right. Little fun music to do programming to, right? That's the name of the game. So I work on this database. You guys know about it probably. I'm gonna make this text a lot bigger too. And one thing that databases have to do is tell you how their schemas are organized. All right? So if you make a schema, you make some tables in your database, it turns out that people want to know at runtime, when you're running an application, something like that, what columns are in a table, what tables are there in the database at all, and other things. What are the types of the columns in the database? All sorts of meta information. And the way that databases do this is it's kind of funny. They expose meta information about themselves using the same interface that they expose your data in. So other tables. And in CockroachDB, the way that we decided to do this was kind of funky, but it works, but it's a little funky. I'm gonna draw a picture. Okay, so I have new improved technology for this stream as well. It's called picture technology, and I'm going to use it right now. So I've got this iPad, and I could draw stuff on it, and it'll show up on the screen. So I'm excited to try this out a little bit. But basically, in CockroachDB, the way that we store information about tables is that we have these kind of protobuf serialized things sitting around on disk in this thing called the descriptors table. Descriptors. And the descriptors table, it's kind of like just a regular table. It's sitting around on disk. It's got keys and values in it. And in fact, why don't I show you what the descriptors table looks like? Because I can do both of these things at once. It's super fun using this advanced technology. If I go over here, I can say select star from system.descriptors. And what this is gonna give me, descriptor, singular. What this is gonna give me is a bunch of gibberish looking stuff. And what this is, it's a table with two things. It's got an ID and it's got a descriptor column. And what this actually is giving you is for each table, a descriptor has a bunch of things, but for the purposes of this, let's just talk about tables. It's got information in this serialized form of what's inside of the table. So let me just do a quick example here. If I made a table, create table, t, a int, and I wanted to figure out what does the metadata for t look like, I'm gonna select from my descriptors again, from system.descriptor, and I'm gonna actually order it by reverse, because I know that my ID is gonna come at the end here. So this new table that I made is gonna get a high ID. So I can say order by ID desk, limit 1. And this is actually the information about my fresh table. Thank you for following. Portuguese Captain, what is going on? How are you doing? Thank you for joining, thank you for following. I appreciate it. Point is though, it's kind of crazy. Like I have this table here, show table T, show create table T. This is what it looks like to a user, to me, but to the database, it looks like this bunch of serialized bytes. Okay, so that's like, fine. Time to watch the stream instead of reviewing the Pushdown PR. Yes. All right, so check this out. in my descriptors table, I have a map from ID to protobuf. Proto. This is great because let's say you wanted to actually just very quickly look up the information about our table. I could say select star from system.descriptor where ID equals 3. And this is very efficient. Whoops, ID equals 53 is what I meant to say. This is efficient. Wait, is it 53? It's 52. All right. If you have been watching the stream, you would know that this is going to be fast because we can push down this filter over here into the descriptor table by asking just for the keys that start with 52. So in our little example here, we'll use a new color. We have 52. We have other things too, by the way. So we have like, 1, 2, ... And then down here, we've got 53 or 50, what is it? 52. And then we've got some more ... dots as well. All this stuff. Point is, it's very good because when I do this query, select star from system.descriptor where ID equals 52, I can have the database just search for this part. It's very quick. Don't have to scan through this stuff. No. Don't have to scan through this stuff. Don't have to scan through this stuff. We're just gonna get this stuff, which is the dream. It is the dream. All right, I'm gonna move this away because it's now distracting. Whoop. So if this is all good though, okay, so basically what the database does when I'm asking for something for something with ID 52, it can look it up really fast. That's what I just said. But here's the thing, all right? The thing is that there's other tables besides just system.descriptor. We're doing virtual table stuff. We're getting metadata about tables. When a user wants to figure out what's in a particular table, they're not going to use this low-level system table here. And they're not going to know the ID of the thing either. They're going to want to use a higher level API. And one of those APIs that we implement is this one that comes from Postgres, and it's this thing called PG class. And PG class is this kind of crazy table that has all sorts of information. But one of the things that it gives you is a way to get the table information given an ID, just like the way that we've done in the system.descriptor thing. So I can say select star from pgcatalog.pg class where ID equals 52. Whoops, except it's actually called rel ID, I think, or OID maybe. And this is gonna give me some structured information. It's really nice, right? It's way better than this crap because nobody could actually figure out what this stuff is unless they were a matrix man of some sort. Or they were the database themselves and they could deserialize it and blah, blah, blah. But no human can read this stuff, and that's problematic for this particular use case. A human, however, can theoretically read this stuff, even though it's a little bit gross. There are some useful fields in here. For example, rel name. So let's do select OID comma rel name from this. And this is actually gonna get me the, let's ignore this. This is actually something from my work in progress. It's gonna get me the ID and the name of the table with ID 52. Okay, so that's the dream. We have structured information. We're getting it from the database in the same way that you can use the database for other SQL stuff. But there's a problem, a big problem, that I'm going to tell you about. And to tell you about it, I'm going to use a version of Cockroach that isn't this work in progress mishmash that I've got going on here, because I think that's going to screw up my example. I'm instead going to use Cockroach 19.2 master version. Cockroach v 19.2 cockroach demo. Okay, so let's make this table again. Once this boots, create table t a int, and then let's do the same thing. We're gonna select from PG class. Maybe it's 51. Maybe there's fewer tables in this version. Hold on. Select star from system.descriptor, order by ID desk, limit 1. 59. Okay, that's weird. The ID changed, that's fine. So in 19.2, it's gonna give you just the stuff that you want, because that's how filters work, right? In the database, we can look at how this explain works too. We're gonna get this virtual table out, which has somehow the information about what the different tables are in the database. Then we're gonna filter on top of it. And that, of course, yes, it does what you want. If we got rid of the filter, it's gonna give you way more stuff like this. It's gonna give you a whole bunch of crap, stuff that I don't want. And if I stick this filter on top, it's gonna render all this stuff and filter it. But that's like no good, because let's come back to our example on the whiteboard here. It turns out that what this thing is doing under the hood, actually, let's move it to the side. I kind of like that. What this thing is doing under the hood is that it's actually scanning over this entire descriptors table and filtering just the things that I asked for. So in this particular case, since I asked for 59, what it's gonna do is it's actually gonna scan through this, all of this crap, all of this stuff. So, you know, we've got like, you know, maybe we have thousands of tables. So we have like table 1000 down here, we have table 2000 down here. And what this thing is actually having to do is, you know, scan all this data and just filter out the stuff that it wants. And that's like no good, really no good, because like I said earlier, theoretically, if you were smart, what you could do is ask for just table 52, or in this case, just table 59. And this is about the quest for making sure that the database can do that. That's what this virtual index filter pushdown business is all about. And the reason that it's tricky, or what does that even mean? Pushdown filter. It means that this filter here, instead of happening on top of the thing that renders all the data in the virtual table, we want to kind of stick this filter lower level, so the virtual table can generate just the things that it wants by reaching in and asking just for this thing, number 52. Okay. That was my intro. Did that make sense? People following? I don't know. But we can go ahead and jump into what we're doing at this point, because I think that's enough intro business. We got a yes. We got a yes in the chat. That is awesome. Okay. So how are we going to organize this now? What we're going to do is that we are going to jump into our IDE. Well, you know, really what we should do is review our diff, because the truth be told is that we've done a lot of work on this already. We've done a significant amount of work on this stuff. And on this stream, I kind of want to make sure that I can finish it up a little bit without doing it from scratch, because that would have kind of taken a long time. Probably pretty boring, because I didn't understand how it was going to work up front. And I'll tell you where we're at right now. And you got a demo of this earlier when I showed this C demo thing in my master version. It was doing something a little bit funky. It was doing this thing where if I selected from this PG class business, which is sort of one of my example cases, with a particular OID, it was giving me like way too much stuff. As you can see here, like 59 doesn't exist and it's giving me everything, which is like fully busted. This filter is not being respected, so I've like violated all of SQL, and that should make everybody very uncomfortable, because that would be a broken database if it were in fact the thing that I'm going to keep. But the reason that this stuff is happening is slightly messy. And this is also messy, right? I'm searching for OID 52 and I'm getting back 2 rows instead of just 1. The reason for this, I'm gonna get into the code now. That was a lot of talking. I'm gonna get into the code. The reason that this is happening is that I'm also gonna make my font a little bit bigger, because I got some feedback. The font was too small. Gonna make it a bit bigger. We're gonna go size 16. It's nice and fat font. Basically, here's how these virtual tables work under the hood. We're gonna peek under the covers. We're gonna find out. We're going to PG catalog. The way that they work under the hood is that they have a little function that gets run when you ask for a particular ID. And that happens to be this populate from table thing. And the particular case of PG class, which is the one that we were looking at, the thing that we're passing in is this bad boy, this function. What this function does is that it takes in a table descriptor, which is that sort of serialized protobuf thing I was telling you about before. So it's like the bytes in that weird table, except they're turned into a nice structured data format using the protobuf magic. So it's a struct that has some information. And then we're gonna just dump out a whole bunch of stuff for this particular table. So we check some fields, we add a row for the table. So this is kind of like that line before in my terminal, which was 52T. This particular line here, the information about table 52, is getting generated by this add row call. We're adding an OID for table 52, we're adding its name, we're adding its type, blah, 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 a whole bunch of other crap that you might need if you were somebody who's writing metadata queries. But then we also do another funky thing, and this is where things get a little bit messy. And that other funky thing is that we add all of the indexes for the table too. All right, so we added the table, and then we're adding a bunch of rows for the indexes, even though somebody asked just for a particular table. And the reason that we do this is kind of like a sad thing that I'm going to use this whiteboard again to demonstrate. So let's see. In CockroachDB, I'm gonna come back to this descriptors table idea. We have our descriptors table, descriptor. I really want to get a little stylus for this iPad too, because that would make my handwriting better. Descriptors table has a few kinds of things in it. It's not just tables, like I said. I'm gonna sort of gloss over that part actually, but it's got tables, which are orange. It's got databases, which are yellow. And it's got some other things, but the one thing that it does not have is indexes. And you might be wondering, like, why doesn't it have indexes if we're also printing indexes out into this PG class thing? And the reason is that when we designed the data layout for this metadata stuff, we decided that since indexes are linked to a table, it kind of would make sense to have those indexes be represented hierarchically. So in other words, like an index belongs to a table. It's not its own entity. And so let's say in our example, we had table 52, right? Inside of table 52, this is sort of, instead of these serialized bytes, which I was drawing before, let's say we have this big struct. We've got some indexes maybe. Indexes, yeah, stylus is gonna make this a lot easier. And we've got index 1 maybe, and index 2 maybe, and index 3. Notice that these indexes, they start from 1. they don't have like the big number, like 55 or something, implying that they would be in the same namespace as tables. They're sort of represented as, like, instead of just 1, you could also think of this as 52/1 or something like that. 52/2/1, 52/2, 52/3. And in fact, this is actually analogous to how we store things on disk, which is pretty neat. If you've seen some of my other videos or some of my other streams, you've seen me investigating the key format of stuff on disk. And on disk, if we have a particular key, like in table 52, maybe we're storing ints, we'd have 52/1 to represent the primary index, and then 5 if we had a key for 5 or something like that. Gonna need to turn that chiming off. 1 second. Cool. So yeah, the thing is though that because of this hierarchy, there's like a bit of a impedance mismatch, you could say, with the way that Postgres does things. And that impedance mismatch is that in Postgres, this PG class table, it actually uses the same OID namespace to represent both tables and indexes. So in Postgres, an index is just as much of a top level concept as a table. And that leads to problems because we don't have an absolute sort of unique ID for these indexes by default. They're sort of made of this hierarchy, right? They're sort of like table ID / index ID. It's a hierarchy, it's a composite ID. And that leads to problems because what do we actually put for this index OID? And the answer is that we have to sort of make something up. That we kind of make up a fake ID and blah, blah, blah. That's sort of fine. But the sort of main problem here is that we can't actually just go to this PG class thing and ask for index, 3,400,000 or whatever, because this is like a hash. This isn't a real ID. We've constructed it just for the purposes of sort of compatibility. Okay, so why did that even matter? The answer is that when we generate this PG class thing, this virtual table, we have to figure out, how how to write these index rows. And the way that we do that is we iterate over all of the tables, and for each table we output the table, but also the indexes. And that's why we've got this mess. And that's also why when I ask for this thing for just table 52, I'm also getting this extra row. It's because we're also outputting this index business. Okay. Now, how does this have to do with optimizers? How does this have to do with filter pushdown? What does this have to do with anything? The answer is that ordinarily with indexes in CockroachDB, and also in general, like indexes in any database, if you ask for a particular range of stuff from an index, so I'm asking for the range of stuff 52 to the end of 52, so just the things in 52, you expect that the index is only going to give you back rows that match. And we've actually gone and violated that constraint. So nobody's sort of backing us up. Nobody's there to catch us, in a sense. Nobody's putting an extra filter here. Whereas before, I remember, I don't know if you remember, we saw earlier that before I added this filter pushdown thing, there was actually this other filter layer here. And we didn't like that because it meant that you have to generate everything and filter it afterwards. But now we sort of have another problem, which is that we're generating just the things that we want, except accidentally putting some extra rows in there. And there's no filter to sort of catch our fail. So that's kind of where we're at. That's one of the things that we've got to fix, is that we have to somehow either decide that this virtual index that we've made up is going to filter its own rows. We have to do that, or we have to have the optimizer stick in an extra filter field on top of this thing. And so let me show you where that would actually happen. I have this sort of convenient to-do. Let me hide this little whiteboarding thing just for a second, because it's a bit distracting. This is the function that we call when we're generating this virtual scan. And what is that about? That's about when the optimizer is going to make this plan, it has this sort of, actually let's use the explain opt mode to see what the optimizer sees. When the optimizer has this plan, it sees scan pgcatalog.pgclass, and here's our new index that we've been adding. That's going to generate just the rows for the constraint, if the constraint is on this OID field, which is our table ID that we've been talking about. Here's the magic index. So this is the code that gets invoked when the optimizer tries to translate this thing, scan pgcatalog pgclass, into a real physical operator, which is this virtual table physical operator. If you run explain opt like this, it's going to give you the optimizer plan. And if you run explain without opt, it's going to give you sort of this more physical plan. I could get into that another time. But point is, this is sort of the thing that does work. And this is the abstract notion of maybe somebody's going to do some work for us someday. This function here, construct virtual scan, is what the optimizer invokes to turn that abstract optimizer node into something concrete. And the way it works right now is that it pulls out, makes this delayed node thing. This delayed node thing kind of has this constructor, and this constructor is formed from this get plan info. This is sort of a mess. It's like this is going to eventually delegate all the way down to that PG catalog generator method I was showing you before. This thing. This is the thing that adds all the rows, and somehow there's sort of some windy path that it takes from getting from here to there, and I'm just going to ignore that. But the point is that this little node here, this delayed node, it has some methods on it, actually. I could sort of show you, I think. Does it have methods on it? It should have methods on it. It's got this next node. You can next it, it'll give you its rows. The thing is, it's giving us too much rows, so we really want to add this filter. And where I left off is that I want to make a filter for this node. And I want it to use that same constraint information that we had that we're passing down into it, sort of do a second filter. And we've got this constraint, but we no longer have the expression that the constraint was generated from. And that was sort of where I got a little bit confused. Like a constraint is essentially, what is it? It's a set of columns, and columns are they're made of ordering columns, and ordering columns are just integers. So they're sort of like these ordinals that tell you what columns we're looking at in the current sort of scope. So that's obvious, I guess. And then spans has the beginning and end of the things that I actually want from the particular columns. So here's a span. It starts and ends, and a key is made up of multiple parts, but I think in our particular case, we sort of have limited things to only be allowed to do a single filter or a single column filter at a time, just because it was getting a little bit complicated. So I think like technically all we would have to do to make a filter here would be sort of to do this hard-coded thing where we figure out, well, what does construct filter take? Let's look at this for a second, because honestly, construct filter, I don't even know. So construct filter, oh right, yeah, this is where I got a little bit stuck, because filter actually takes a filter expression, and we would have to turn our constraint back into a typed expression, which is the sort of AST abstract syntax tree version of these constraints. It'll have an actual formula like a equals 5 or a less than 20 or something like that. And I think that doing that would be sort of hard. Another option that I could look at is just sort of re-implementing this filter inside of delayed node, which might be easier. So in other words, when you run this thing, instead of just giving out the values from this plan.next thing, we could do the filtering on demand. So that's an option. I think I might try to do that. The last detail though is that like, I think the thing that gets created, this delayed node's a bit of a hack. It sort of like doesn't know its own plan until it gets started. As you can see, it sort of, this start exec thing happens when, at the beginning of a SQL query, you run start exec on all of your nodes inside of your plan before you get any data out of them. And I think what this thing does is it calls this constructor thing, and the constructor gives back a new plan, and it sort of swaps itself out. So let me actually investigate that real quick. Like what do we pass in for our constructor here? We pass in a little closure that calls another constructor. Oh yeah, and this constructor is given from this get plan info. So maybe, okay, so let's see, what does this thing give back? Maybe what I'm sort of thinking is that the filter should just live in here, and we should plumb the constraint down into this constructor thing. Because that way you wouldn't have to pollute delayed node, which I know is used for some other things. Right, so this is actually the code. I mean, this is interesting. Maybe it really would be good here, because this is the code that I added that actually does the virtual index population in the first place. It says, do I have a constraint at all? Normally this is gonna be false until we're pushing these constraints in. Does it do anything? And then for each of the constraint spans, it assumes that they're length 1. This is what I was saying earlier, because I haven't figured out how to do that yet. And if it doesn't have a single key, so if it's a range scan, we also give up, and we just repopulate the whole table. And so basically like we just have to have a little filter guide here. Oh, maybe add row. Oh, this is kind of an interesting idea. So this is the function that we call that actually, given some datums, adds it into this little container thing that we're going to spit out later. And this is something that I think, Rohan, if you're still on the stream, you've been messing with this thing. And maybe I don't know if this is gonna like completely change after your thing. Probably not, because I think add row is now gonna be this sort of like blocking channel thing. So we can still put the filter in between this add row and this add row, I think, or something like that. I think this is gonna be the neatest thing though, because it really should be very straightforward. If we can just get the constraint plumbed into here, then all we would have to say is like, if datums of I, and then I guess this I is gonna have to, I is basically equal to the constraint position. And if we can say if datums I is equal to this constraint, then we add the row, otherwise we do nothing. I think that's pretty elegant. Obviously this code doesn't compile, but And this would be dot equals, I think. Dot compare. Has to have an eval context. Man, how much of this stream have I spent just plumbing eval context everywhere? I feel like that's been like 90% of these streams. It's fun, really fun. Because I'm gonna have to, oh no, I have a planner. If you have a planner, you have an eval context. So if I compare these things and the result is 0, then I can go ahead. So what is constraint right now? This is the wrong kind of constraint. What we need to do is somehow trickily get the constraint up into here. And do we have it down here? Is this where we turn the constraint into a datum? Yes, it is in fact where we turn the constraint into a datum. So I think we just need to populate this add row thing just needs to come down here after we've figured out. Oh wait, we already have the span way up top, so I think we can, oh I see, no, it's because we have multiple of these things. I see, so this little closure has to be defined inside of this loop. That's fine. That is completely fine. Let us, okay, so this is going to be our constraint datum. And we can put it up here. And then here's where we're gonna make our special add row guy. Nice music selection, thank you. Thank you. It's kind of fun, right? It's like a little deep tribal. Relaxing, yet intense. You know, it's focusing and yet not too crazy. Not too much, not like any metal. I don't know, sometimes people like to listen to metal. If you're a metalhead and you're listening to this and I've offended you, I'm very sorry, but I just can't deal with it, especially not while I'm working. It's like, oh, it just crushes me. All right, so we've got our constraint datum, and now we just need to figure out how to figure out the ordinal of the column that we're trying to filter. Where do we get that from? Surely we have it here already somewhere. Surely we have it. I think it must be part of index. So probably this has to come up over here. Grab this guy, stick it over here. Now what is index? Index is a virtual index. I see. So probably what we need to do is teach these virtual indexes when we define them. By the way, that's something I haven't shown off yet. You can define virtual indexes yourself if you want. If you're an author of a virtual table, you can just kind of populate them on demand. You can say, here's my table, it's got a schema, it's got some stuff in it, and then it's also got some virtual indexes. And each of these virtual indexes have a populate method that you can define yourself. But I guess what I'm saying is that maybe what you should also do here is sort of say, you know, constraint ordinal? No, I don't know. Like I think that probably this information is already available in a more pleasant way. I just need to figure out what that is. So what do we have? I mean, what do we have here? We have, I think this is just so deep in the execution code that we don't, oh, maybe we have index though. Maybe that would be enough. Is that gonna be enough? What does index have? Index descriptors. By the way, these index descriptors, it's very meta, right? I was telling you this is meta, and I wasn't lying. These index descriptors are the same things that we're actually going to use to generate the data for this particular example of the virtual table that I was looking at. Like those were what those nested little dudes were. Like if I go back over here, pop up my whiteboard, maybe this is just not comprehensible, I don't know. But the point is that like, this is the table descriptor ID. This thing is the table descriptor. And then this little guy, this little buddy, is the index descriptor. And we're looking at it to use our own, oh my God, this looks like a mess on screen, doesn't it? I would need to sort of black out my background. I could go like this, maybe. I could also hit up this view. Check out this view, you guys. Boom. This is a fresh view for this stream. You guys are the first to see it. It's got a picture of me that somebody drew. And no distracting background. Anyway, big tangent. This is the index descriptor. We're looking at it. We're also printing it out. It's very meta. Great. Good stuff. Back to our lives. Picture needs a caption. Yeah, I should get one of those captions going. Okay. Okay, so the problem is that this index thing, it now has, we should call this virtual index because the word index is now overloaded and it's gross. And I think down here, all we have to get this ordinal position is to say index dot column IDs of 0. I think this column IDs thing tells you an ordered list of column IDs of which the index is comprised. So the 0th column ID in here is going to be the ID of the column that is being constrained. However, we still need to figure out the ordinal position of the column in the row that we're getting. And I don't know if that's always going to be the same thing as the ID. Although I think actually in this case it might be, because is this where you come to learn the quadratic formula? I don't know. You tell me. Let me know what you think about this null bitmap. Wait, it didn't work. That also didn't work. There we go. This is the quadratic formula view. All right, you got your descriptors, and then you just move down over here, make a new line, and then you got some formulas. A plus B equals C. Is that a formula? Is that what you were looking for? I don't know. Let's go back to business. Back to business. Okay, so we've got our we've got our column ID, and the question I have right now is when we're generating these things. The wipe, exactly. Can it be a star wipe? I think it might be able to. I don't know. Do you know how to do that? Let's find out. Let's find out. You've piqued my curiosity. Check out the secret sauce, you guys. You've piqued my curiosity. How do I get a star wipe? Scene transitions. Give me a new scene transition and give me a swipe. No. Properties. Here we go. Where's the star wipe? Look at all these wipes you can play with. I don't see a star one. Let's try out a spiral. Oh yeah. All right, let's hit that. Let's hit that. Ready? Did it work? Oh man. That's just fantastic. That is just fantastic. We're gonna keep that. We're gonna keep that. And we're gonna get into business. Poggers, yes. This is a very poggers wipe. Very poggers wipe. You know, it is like you're watching a science video. And one thing that I'm confused about is these keyboard shortcuts, I don't think they're working from everywhere. So I think I have to open OBS and then I can do it. But I think it's because I installed macOS Catalina. Have you guys done that? Catalina is gonna fuck your shit up. It's really gonna mess everything up. So don't do it if you can help it. All right, okay. So our indexes, our indexes, they're special, you guys, they're special. They're special because we are the ones that constructed them. It isn't like a general index, and I don't think that it really matters all that much because I know that we constructed them. Where did we construct them? We constructed them in this thing called populate virtual, no. What the heck did I call this thing? What did I call it? Init. Sometimes my brain is just like, did I call it construct? Did I call it init? Did I call it populate? What the heck did I call it? In this case, it's init. Okay. So here's what we're doing though. We're parsing the schema of this fake table. We make a descriptor, and then for each of these indexes, what does this mean? What do you mean for each of these indexes? For each of these indexes, how the heck do I get the ordinal position of a column without, this always kills me, you guys. This is always like the most annoying thing. Because I think I would have to pass it in if I actually wanted to get it from the optimizer. And I think the optimizer is really technically the only thing that's going to know the ordinal position of a column. I would have to pass it in, I think. Let me just try something and then watch it fail. That'll be always fun. That's my style on the stream. You try something and you watch it fail. So, where the heck was I though? Where the heck was I? Was I down here? I think I was down here. I think I was down. Wait, where was I? Add row. Yes, I was down here. So the 0th column ID of the index is the thing that we're constraining. That is what it is. And yeah, but the thing is that we're in this random place. We're in this random place. We're like deep in this execution code. And this execution code doesn't know anything. It's very sketchy. It's very meta. The virtual table thing is sketchy and meta. And I don't know if we could really know that at this point necessarily. Yeah, it's the thing that shoves them all in a values clause. Well, that's going to get fixed. I mean, the values part is going to get fixed for in a different project. But essentially, yes. But maybe hold on a minute. If we are selecting a subset of the columns, we need a projection. How does this thing do it? This is where it's at. For each of the needed columns, we add them well, wait a minute. I think that if this thing is able to just make a projection on its input without doing anything fancy, in other words, it's literally just saying needed has ordinals, and it's getting an ordinal by asking for the ord minus 1th column in columns, which means that these columns here are ordered by nothing, or they're ordered in the same order as their quote-unquote natural ordering. The question is, yeah, what the heck is that natural ordering? This thing is actually returning what we want, so maybe we sort of know it on the inside. We already know it. We're like literally inside of this thing. I think the order, okay, here's what it is. The order of these columns are ordered in the order that they are outputted. So in order to figure out what index a particular column ID is inside of this slice, which is going to be the same order as the datums, we just have to search through them, perhaps? Could that be it? Seems janky. Oh wait, look, you guys, the mapping is null. We do it right here. We're checking the ith column is the ith. No. I already knew that. I already knew that. I think I still have to do this thing that I'm talking about, where I have to find what position this particular column ID is within index.columns. So let's just go ahead and do that, shall we? We'll do it up here, where we're looping over the indexes. Where are we looping over these indexes? We have one already up here at the top. So we can basically do it right here inside of our if. We'll say, figure out the ordinal position of the column that we're filtering on. To do Jordan, there is probably a better way to do this. Okay, so I bet also these indexes, they probably have little methods that do some of this stuff for you, right? Oh, it's not the index. No, it's the tables, right? So I think our table, which we don't have a reference to, or does the index have its own table as a reference? This is annoying. Do I not have my own table descriptor thing up in here? That would be pretty frustrating if I didn't have that. I don't see why that would be the case at all. But luckily for us, we only have one caller, and here, of course, we do have the table, so we can just pass it in, no problem. That is no problem. Table, SQL-based.table descriptor. Okay. Now go to my caller, and I'm going to pass in this table thing, get us more information. Opt virtual table dot desk dot table desk. Right. Is this gonna be good? This is gonna be good. So then we can say table dot find, no, table dot, what happened? Base, that is just the wrong word. All right, so I think this thing should have a method called like find me the column with an ID. How could it not? Find index by ID. Column IDX map, there we go. That's what we want. Column IDX map returns a map from column ID to the ordinal position of that column. That's it. I just passed column by ID. Oh, what? Column by, oh, I see. Wait, how crazy is this though? Wait, it literally, there's two ways to do that. One, you can use this method, which loops over all the columns searching. And then the other way that you can do it is that other thing that I just said, column IDX map. I feel like I want column IDX map because column IDX map is gonna give me the ordinal position, whereas the other thing is just gonna give me the column descriptor, which doesn't have the ordinal. This is the dream. This is what I want. And then I'm gonna pass in the 0th column or something. Index dot column IDs of 0 dot, no. TFW, you have to allocate a map. Yes, I've been there. Ordinal. Yes, this is the dream. Okay, so if this thing fails, it's gonna all blow up. But if this fails, it's gonna all blow up. Okay, so we've got our ordinal, we've got our constraint. And then all we have to do is inside of our add row, we're gonna filter this little buddy. So if datums of ord, datums of ord dot compare blah 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 is, yeah, I think this is good. I think this is good. And we can call this, instead of calling this ord, let's call it constraint column ord. Okay. Okay, so if we compare and it's 0, we return it, we add it. All right, so who is paying attention? What would this have done? Going back way to the beginning, the goal, the hope, is that when we recompile this thing, which now may take a long time, the goal is that this thing where we returned too much crap for OID 52 will no longer happen. This thing will no longer happen. That's the dream. I made a change today that introduced 200 compile errors this morning, and I've worked my way down to 95. I'm very proud of you. I think that's good work. I think that is excellent work. I'm proud. I'm happy to hear it. So how's Rust, right? Like Rust. Are there more compile errors in Rust? I would imagine so. It's so safe. It's a safe, memory safe language, which as we know maybe doesn't mean that much. I don't know. You think the more safe a language is, the more errors that you might get when you do anything. It's cool if you don't want to see the way your program is wrong and just be told that it is so. Yeah, I like that. That's the you are wrong method of doing stuff. Okay, not enough arguments. Oh yeah. I just left some like weird crappy code. Let us delete it and fix it. Bang. Boom. Rust seems so hard. You know, yeah, I think Rust does seem hard. I agree. My friend Paul was also streaming today. He's currently fun employed, and he was making a game in Rust. How about that? That seems like kind of hard to do, making a game in Rust. Like, I don't know. It just seems like you'd move kind of slow. Prefer debugging runtime bugs and compile errors. Yeah. It depends on how good the compile errors are, I feel like. Because I feel like I'm sort of the opposite, but how come this isn't working? Oh, I see. I edited my add row to live inside of the, oh. This is gonna be a problem. This is gonna be a problem. This is gonna be a problem. What the heck? Hold on a minute. I think I messed something up real bad. Okay, so basically what's happening here is that before we didn't have this thing where we might have constraints, and so we just generated all the data using populate. Now we have constraints, and the thing is that there could be multiple constraints, so we could have two spans in our constraint. And is this a top level or is it a top level and? I always forget. I think it's top level or, which means that if I get a constraint with two spans, it means that I have to give back both of them. Yeah. Or is multiple spans. So I think the thing is that right now I'm just running this populate thing once for every constraint, whereas I actually have to run it, or sorry, once regardless of the number of constraint or span things. But really what I have to do is I've got to run it once per span in the constraint with the filter. And if there's no filter, then we just have to run. Oh, I see. I just need to have two add row functions basically, or something like that. Or I could like have add row reference a filter that I change in between every loop. Would that be good or would that be horrible? Let's why don't we do that? That sounds super lead. Okay, grab add row, stick it back over here. Now, yes, this is gonna be not working. However, or should we make a little add row constructor closure to make things super tricky for no reason? I don't know. The chat is freaking out about Rust. I think that they don't, yeah, I don't know. Rust politics, that's a whole subject matter, and I'm not an expert in that subject matter. All right, so what we're gonna do is that we're going to, can I change the signature of this guy, or is that a no-no? It's probably a no-no. I think I just need to make a bunch of closures, which I hate, but I think that's just life, you know? I think that's just life. You know, I'm gonna do it hacky. Okay, I'm gonna say var constraint datum, tree.datum. I'm gonna say var constraint column ord int. And down here, I'm gonna say if we have a constraint, apply it as a filter. Otherwise, just pass, if the filter passes, or we had no filter at all, add the datums to the row container. Okay, so we'll say if datum, if constraint datum is equal to nil, or, and then we're gonna, oh, is this gonna even work? Like, is this how closures work? Is this how closures work in Go? Do you guys know how closures work in Go? Like, let's say I define a closure and it closes over a value. I think I would need to make these pointers or something. Let's do it, why not? We're just gonna go wild. We're gonna go wild. Gonna go wild with pointers. Values should work. But here's the thing, Peter, I'm gonna edit the values. I'm gonna edit the values. Down here in my loop, I'm making a little filter loop thing. And I'm gonna run it a few times with different filters. And if I don't make them pointers, then I feel like if I edit these values, it's just gonna do nothing. And the closure will just act the same the second time. Know what I mean? Okay, I'm gonna try it. We can do the go playground. We're gonna do the go playground. Go playground. Okay. Foo is equal to func. It's gonna take nothing. It's going to print out some stuff. Format.println. Make it an int. And our int is gonna be called I. This is definitely not gonna possibly work, right? I is equal to 5. And then I'll say foo. And then I'm gonna say I equals 4. And then I'm gonna say foo again. Boop. Huh? What? 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 All right, well, I've been proven wrong. Panda wine, hello my queen. I'm not sure who you are and why you would be calling me a queen, but I don't think I like it. Okay, so your example was pretty much similar to mine, and it has also proven that, well, this is a little different, but yeah, same idea. I need to upgrade the Go compiler in my head. Yeah, I feel the same way. My head compiler is like, it's all out of whack. It's out of spec. Didn't follow the spec. Does Go even have a spec, or is the spec the compiler? Is it one of those things? I don't remember. Okay, so point is, let's go back to what we were doing here. Get rid of all these pointers. Get rid of this stuff. And down here, we can literally just set these things. And we should be good to go. And then down here at the end, where we have our special populate loop that is everything, which we should probably comment about, by the way. If we didn't manage to constrain the virtual table at all, we need to populate the, wait a minute, what is this about? What is this about? I think that there's some busted stuff here, to be honest. Oh, I see. No, it's good. It's good. Okay, so here's what's happening. Here's the summary. We're populating a virtual table, and if we have a constraint, then for each span in the constraint, we are going to try to add all the rows given the constraint. But there's some bad cases here. There's some bad cases here. And the bad cases is going to be active when I've set this partial business. And this partial business is about that case I was trying to talk about earlier, where we can't figure out necessarily whether an input has a match in the underlying table. Wow, that is a mouthful. Let me just give a quick example. We've got our PG class thing. And our PG class thing has a few kinds of, let's make this a little bit clearer. Select OID from PG class. Let's also make a table. Create table T A int. Now our PG class is going to have a few things. It's going to have some like weird giant numbers. It's going to have our table ID here. And it's going to also have some other giant number, which is the hashed or index ID. And this one is the only one that we can actually filter properly, because it's the only one that you can actually use a lookup on to get into system.descriptor. These ones are like these virtual ID things, and we can't possibly look them up. Just won't work. So the way that I've done things, and it might be horrible, is that if the table is like this and if sometimes can't be looked up, then I mark it as partial. And then if it's partial and we don't get a match, then we give up and we just populate the whole table like we would normally. So that's kind of nasty, but like that's just reality. So I think the point is that if we do get into this give up scenario, we have to like reset our constraint datum and constraint column ord, which is very hacky, but I'm just going to do it for now, and maybe I'll clean this up off stream. So constraint datum equals nil, and we'll say, yeah, that's all we have to do. If we didn't manage to constrain the virtual table at all, or if we were trying, trying to constrain a virtual table but failed because we had no match on a partial virtual index, we have to fall back to filling up the whole table and filtering it. Okay, so this is kind of a big problem now that I think about it. Hey, thanks for the follows, Jandy RP and Pandawine. I really appreciate those follows. What happened to the dancing cockroaches? That was just the CockroachDB stream, and I don't have it on this one. I could, if you want to see it. I'll just give you a hot preview. Looks like this. Now my face is a little cut off. There's some things wrong with this, but it does exist. I think it's just sort of rotted a little bit. Gonna go get rid of that though. All right. So here's the thing. For all this talking, I have just realized that there's still a big problem, which is that this filtering business that I've added, it's specific to the particular span that we're looking at. So as an example, if I had something like select OID from PG class where OID equals 52 or OID equals 60, besides the fact that this doesn't work at all, well, the reason that this doesn't work at all right now is the same thing that I'm worried about, which is that in our little loop, we first constrain this one, and that works because we do find a match. Then we constrain this one, we don't find a match, so we have to assume that there's no match and we have to populate everything. And in that populate everything step, we actually need to apply this entire filter, right? And not just like the last one that we looked at, which is what we're doing right now. So I think in order to do that, we have to get slightly smarter. But I think it actually might simplify things as well. Because our filter here, we can just make it always exactly the same. We don't need to populate add row inside of this closure. We can get rid of this whole hacky crap that I was complaining about. So I think the way that that's going to work is that we're going to iterate over each of the constraint datums And we're going to have to populate each of the constraint datums by iterating through the constraint spans. So let's do that up front. Let's actually just do that up front over here. So we'll say for, actually we'll just sort of copy this loop over here, because we're going to want to use the same technique. Yeah, we'll just grab this whole thing, stick it over here. Okay, so for each of the spans in the constraint, we're going to grab the span. We're giving up here because we haven't implemented this yet. This is in case you had a multi-column constraint. And we're going to, with range scans, we're also gonna, yeah. So we'll have to make a, I think what we want to do is like make a little array of constraint datums here. Although now that I think about it, you could actually just, there's no need to pre-process this stuff. You could just do it on demand inside of this loop. So we have all the information we need over here. What we want to do is we want to say, yeah, we'll just add, let's stick with our copy and paste strategy, but get rid of it up here and come back into our little add row guy. For each of the spans, we're searching for our span start key, and that's going to be our constraint for the moment. So we'll say if, I guess we want to pull this out ahead of time. This is the datum that we're comparing against. Datum to compare. Filtered datum to compare, datum to filter. So if we see and we also need a little boolean. We need var bool var matched, and we can say matched filter is equal to false. And if we see that the datum to filter dot compare p dot eval context comma, and then for here I think we just need to get our spans start key dot value of 0 or something. Is that right? Equals 0. Then at this point we know that we've passed the filter. We can set matched filter to be true and immediately break. And then I think we'd be good. What's wrong with this? We have the wrong return value here. So we just want to return the error no nil. Okay, so our filter is true. We get out of this loop and then we say if matched filter. There's one slight problem here, which is that I think this starts out as false, but if we had 0 spans, then we're always going to pass the filter. So I guess we could say match filter equals constraint dot spans dot count is equal to 0. Yeah. So that's cool. So we made a little filter. We look at our spans. If we have 0, we know we're good. We can just leave. Otherwise, we look through each of the spans. We get the start key of the span, assuming all of these other preconditions that we're hopefully gonna lift at some point, just probably not right now. We compare it. If it's 0, we matched, we break, we add the row. All right. So can we delete other stuff that we added before? I think probably. Some brain 5 right there. I don't know if it's that brain 5. We can get rid of all this stuff, this constraint datum stuff. Oh, but we can get rid of something. We can get rid of something very big, which is that. Wait, can we? No. No, I think this is right. All right, let's compile. See if it compiles. This would be a good time to, okay, constraint datum declared and not used. Right, I have this extra stuff that we can just get rid of. What's up with this? What's up with this? Constraint column org. The constraint column or is always going to be the same. But how do we get it again? It's this. It's down here. Constraint column, blah, blah, blah. Yeah, we can pull this all the way up to the top. I think that's valid. I think that's valid. I think that's valid. I think there's some funkiness because in the case where we're not doing any filters, then I think the way it works is that we've defined this sort of fake primary index that does have a column ID, and like unsure if this will have like valid enough values to make all this sort of work out. Yeah, whatever. Well, let's just find out. Let's find out. We can't know till we try. Okay, so while that all happens, I'm gonna pull up my my whiteboard just because I have it, and yeah, what am I gonna do with this whiteboard right now? I don't know. I just want to draw stuff. Let's draw a big fat smiley face because I'm having so much fun. Whoop. Art skills, my friends. And we can make it a little happier. Are you guys artists? I'm not an artist. Nor do I have glasses. Okay, all right, let's get back to business. Back to business. Oh yes, we got an immediate seg fault. That is the best. That is the best. We can make him happier, draws glasses on him. Exactly, exactly. Nerds are the happiest, and all nerds wear glasses, and all glasses wearers are nerds. It's simple. Okay, what is going on here? 343. I knew that this was gonna be messed up. I knew it. I think the problem is that this primary index business doesn't really actually have any columns or something like that. I don't know. We have to decompose these two things because otherwise we're not going to know. First index column. We're not going to know which one crashed it. And unfortunately, we have to redo this whole thing now. Yeah. Sometimes you just gotta wait. Oh, you know, so here's a quick anecdote, you guys. I wanted to, so these transitions, right? Like they're pretty fun. You can see that I'm having fun with the transitions. You can have OBS trigger the transitions with a global hotkey. And I was thinking, well, with global hotkeys, you have to make sure that the hotkey doesn't interact with any other hotkey on your system, or else you're gonna be really sad, right? So what I did was I have also this whole keyboard business setup stuff that I sometimes play with, where you flash a firmware into the keyboard. The keyboard, you can make it do whatever you want with firmware flashing. I flashed this firmware that I thought was going to be good to make some special key bindings, and then I bricked the keyboard. So I got really freaked out. Like an hour and a half before the stream, I was like, oh my God, my keyboard doesn't work. And I eventually figured it out, but it was a really scary moment, and I wasn't into it, so I don't recommend that you do that. Okay, line 343 again. Yeah, so basically we don't have any column IDs in this index at all, if it's the primary index. So what the heck should we do about this? I mean, this isn't gonna ever get evaluated if we don't have constraints and we're on this primary index thing. So how do we just not do it without screwing up the other code? The answer is that we need to synthesize. Maybe we just set constraint column or to 0. Var constraint column ord int, and then we say if we have any constraints or something. I don't know. If constraint is not equal to nil. No, wait. I thought we already have a big condition for constraint not nil. We do. Let's pull this out into a condition here. Constraint constrained scan. We're gonna grab this condition and stick it way up over here. And then we can say, if constrained scan, then we mess around with this stuff. Okay, that might be a bit better. That might be a bit better. Let's find out. The foot pedal. I think the foot pedal would be good. I want to figure out how come it doesn't let me, oh, you know, I bet I know what it is. I bet it's that in system preferences, I didn't give the stupid OBS permissions to listen to everything. And this is just this new Catalina stuff that's really messing with me. Security. So yeah, thanks for stopping by, Null Bitmap. Appreciate it. Always nice to see you on the stream. Okay, input monitoring. I think I need to like add an exception for OBS for this or something. So how do I get OBS? OBS. What if I just do this? Oh no, definitely don't quit OBS. Okay, never mind guys, I'll do this later. No global hotkeys for us today. Okay, still unhappy though. 372. We run into problems, line 372. Oh right, so yeah, this is so gross though. But we can just pull this whole thing out into a goal, to a condition, I guess. I don't know. Well, let's say match filter is equal to I think I'm just trying to be too tricky for no reason, but that's fine. That is fine. We'll say we'll just wrap this whole thing in constrained scan, I guess. Start here. We'll say matched filter is equal to not constrained scan. Simple. Simple. And then we'll say if constrained scan, then do all this stuff. I think that'll help the situation a little bit. Right? I think it'll help. I think it'll help. I think it'll help. I'm gonna get rid of this drawing stuff for now. Yeah, I should probably just write unit tests for this. I even have unit tests for this. I don't know why I'm bothering to recompile the whole thing. Next time I'm gonna run the unit tests, okay? Save everybody a little bit of trouble and waiting and boredom. Linking, that's the problem. It takes forever to link stuff. Okay, here we go. Okay, it did not crash. Our first thing was a success, it didn't crash. We're gonna create a table. Let's look at what's inside of our descriptors table. Select star from system.descriptor order by ID desk limit 1. Okay, so our new table has ID 52. Let us select OID rel name from PG class. First of all, no filters. Hashtag no filter, right guys? And then I can say where OID equals 52 and we'll see if we did anything right or not. The moment of truth, drum roll, please. Ha! Okay, so that's promising. That is quite promising. Okay, so now let's also test the case where we cannot actually constrain the index despite the fact that we have a filter because it's one of these sort of fake giant IDs, like so. This should also return just this line, one would hope. It does, yes. Let's get some poggers in the chat. That is awesome, you guys. We're crushing it. Okay, so when's the PR? I mean, look, the PR is out. Does this count as pair programming? Don't need to have a review if you pair program, right? Roll safe. Does it work for this one? Works for this one. This is pretty good. This is pretty sick. I'm happy about this. Wait. Let's also make sure that the pushdown is actually happening and we're not just making a filter. Explain. Okay. Okay. This is solid. Let's do another thing. Show create table T. This is a pet peeve of mine that this thing used to be really terrible. Let's look at the explain for this guy. I mean, good lord. Good lord, look at this plan. It's so complicated. But the question is it efficient? Whoa. This looks... But, oh, what? Is this like printing text in a... What? Who understands what's going on here? I certainly don't. Concat the new line character with the create statement and when. This is wild. I guess it's just some string concatenation stuff and it looks weird, but this does not look like a normal plan. I had a heart attack. I was like, oh my God, did something like completely break? I think it's good. I think what this is saying is that it's gonna print out this thing if it doesn't have partitions or something. What does the show create table in planner do? I think I did this. I think I shouldn't be so surprised because I literally like did this. Yeah, exactly. Case when, when select star from zone configs is null. Wait, this does not seem right. I think I maybe just didn't quite finish what I was doing here. Because that is not legit whatsoever. I also need to filter. Oh, wait, no, this is actually right because zone configs is over here. It's a common table expression. This is legit. This is super legit. Very into it. Okay, anyway, so the point is though that like, yeah, we've got a filtered scan here, a fake filtered scan, and we're actually going to just go and delegate to system.descriptor like we were talking about in the first place, generate just the rows that we want. And I think this is now gonna be like efficient, you know? Let's use a tool, one of my favorite tools, set auto trace equals on comma kv. Let's run this show create table and see what it does. It's doing a lot of stuff, probably way too much. Hold on, let's try this one more time. Oof. So show create populates the create statements table. No. Well, it does. But I made the show create statements thing have a special index, so we should be good. I'm pretty sure. That was one of the things that I did in this PR because this particular problem was very motivating to me. So create statements table is a make all relations PG catalog table, which does automatically create an index based on the descriptor ID. So, I mean, that would be good if it was working, which so far I can't tell if it's working because it looks like we're doing a lot of scans. We're scanning the entire namespace table for one, so we haven't fixed that just yet. Maybe that's unavoidable. I don't know. So ignoring all that, what happens when we get to the descriptors table? Wait. It's just a lookup, not a scan? No, this is a scan.
In this universe,
because it says scan.
Process time linearly.
But I think so we should probably try to fix this.
But outside of our space-time, from what would be a fourth.
It's reading one row.
Perspective.
I don't know. I think that's reading an entire index. I think this is the primary index of namespace table. So that's whack, dude. super whack. But no matter. The point is that once we actually get down to business, which is looking up the descriptors, what is this again? Select T reg class OID. So this is number 52. When I actually get down to business, reading from the descriptors table, we should hopefully see 52 somewhere, but I currently do not. What is the idea of the descriptors table again? It's 3. So we should see something that says 3/52, but we don't. So how does this even work? You know, it would really be nice if this thing would print out the name. Like, don't we have something where it pretty prints these names? I thought we did. We have it for namespace table. How come we don't have it for the other stuff? Where does that happen? Let's add that. It's like, let's sharpen our tools while we're doing this stuff. Namespace table. Where does this get pretty printed? Where is that happening? Probably there's some quotes around it, right? No? Where the heck does this thing? It's got to be in some kind of like keys package thing. Printer, here we go. Okay, so if you see namespace table min, namespace table max, you print out some special stuff. I want to do this also for, this is some like old school code up in here, but I also want to do it for descriptors table. Descriptor table. Okay. Let's just copy this stuff here. Descriptor table max. Okay, so the point of this is just to make our lives easier when we're debugging, all right, y'all? All right. This is start key of system dot descriptor. Well, I don't know what this is saying. System that does not reside in the same range as other system tables. I have no idea what that's about. We could probably, I mean, we could probably even do better than this, right? It's like, what the heck? I mean, shouldn't we be able to automatically do this for all system tables or something? I don't know how this weird thing works. Key dict. We probably could, but I'm not gonna mess with it right now. Descriptor table min, descriptor table max. Okay, so anyway, I'm still confused though. That's the thing, I'm still confused. I'm still confused. Where is the thing where we actually fetch? Oh wait, I think it's right here. I think it's just way up top and then we do a whole bunch of other crap down below. So I think we're good. Show create table T. Wait. It's ID 52. And look what we do. We scan the namespace table, and then right afterwards we wait, I just saw it. Right afterwards now I'm lost again. All right, we're gonna recompile so we can get that debugging information in there because it's gonna be super cool. It's gonna make a lot of lives easier. Maybe mostly my life, but hopefully some other people's lives. Oh yeah, if you change keys, what depends on keys? Like nearly everything. This entire database depends on that keys package. Okay. You guys like this music? I think this music is a Pepe jam, as they say. This is like my Ninja Turtle, my friendly Ninja Turtle that we look at while we compile. Nice, I'm glad you're enjoying. That's good. I was hoping that the music would serve as a useful thing for people. Hype but not too hype, exactly. All right, so now I think if I do this again, create table T, show create table T, set my auto trace, maybe we'll see some more useful stuff. But do we? Descriptor table? No. Okay, that whole thing didn't really seem to work. What's the deal? Oh my gosh, I called it the wrong thing. That's so dumb. Descriptor T. I'm gonna have to do this whole thing again. Yeah. That's all right. We like compiling. We like giving our computers a little bit of stuff to do. It makes them feel good. I bought this tube of tomato paste the other day because I think that tomato paste is supposed to be good as a thing to use in your cooking. But I had this moment, you know, I looked at it and I said, I know that you're gonna go into the refrigerator and then not get used that much. And so I had this moment where I looked at the tube and I said, enjoy your new life here in this refrigerator. And I felt at that moment, I like imbued it with soul and I felt bad. I felt really sad for the little tube of tomato paste because I was imprisoning it. It has a soul now. I gotta use it. And I feel the same way about the computer. You know, the computer, if you don't make it compile the database a lot, it's gonna feel sad, underused, and alone. So point is, just make sure that you're compiling stuff frequently. All right? Only you can prevent sad tomato paste tubes. I did not use the whole tube in my next meal, although I should have. Oh no, my face is gone. Come back, face. I did not use the whole tube in my next meal, but I should have. That would have been cool of me. Okay, let's go. Are we gonna get lucky this time? Show create table T. Yes, okay, look at that. See, that's nice. I'm into it. I'm very much into this. I'm very much into this. It's so cool. A teaspoon of tomato paste and 2 cups of rice with some garlic and bay leaves is a great, simple way to use it up. Dude, that sounds amazing. That sounds really good. I'm gonna check that out. So here's the thing. What is up with these weird long keys? Like what? What even is this? It's a real mystery to me what's going on with this. Like, hold on. Let's see what happens when I say select star from system.descriptor where ID equals 5, just to like make a really simple version of this that we can hopefully validate that things make sense here. So we should see something. Okay, wait. Actually, let's even get crazier. We're gonna put an ID that looks really special, like 9999, so we can see it visually. What is table 3? It's accessing a family. So yeah, this looks right though, right? Like, look, query next range at. Is that accessing a family? Is that what's happening, you guys? I'm not 100% convinced. What is this key? This is a crazy key. Descriptor table 31321. Like, who's ever even heard of that? That's wild. I think something's like kind of messed up with the way that we print these, but I don't think it's that big of a deal. Point is that this actually looks correct. So if we have show create table T, which we know is a particular ID, we should really see that ID that looks just like this. Descriptor table 3152. That's what we're hoping for, right? 52. Okay. So we're gonna put in our little search bar to descriptor table 3152. Oh, it was right there all along. It was right there all along. But let's make sure that it still happens when you do show create, because that is our hope and dream. Yes. It just happens weirdly high up. Like we also do all this other crap down here. I mean, this is like some more stuff that we could probably optimize later, is my guess. But for now, I'm very happy with this. I think that seems really nice. Really, really pleasing. So what does this mean for the work that we're trying to do though? That's my next question. That is my next question. Zones, yeah, it might be the zones, I don't know. I needed to, like, what did I need to do? I needed to make sure that these things get filtered properly, which I just did. I needed to make sure that they got sorted properly, which I just did. So I feel like we might be sort of done. But let me run these logic tests, because the logic test is gonna be the true arbiter of whether I made some stuff screw up. Make test base logic. Make test base logic files equals PG catalog. I think I was having trouble making this one work before, but I think it's gonna work now. I think it's gonna work, and it might have, yeah, I don't know. We'll see if it works. I think it's gonna have a higher likelihood of working blah, I believe, is like, I don't even know where it's coming from, but we can track it down by figuring out what this stuff is. Let's add some good old print lines. You know, maybe it's time for the debugger. No, I think it's still time for print lines. Printing table details for table with ID, data source dot ID. I think that whatever is generating these IDs is like kind of confused because I think it's possible that the way that we represent these virtual tables themselves in the optimizer uses a different way of getting IDs than the table IDs that we declared them with in the first place, because of the fact that we're worried that since the virtual tables can vary their contents based on the database that you're in, we're worried about that. And so we have to give them different IDs or something like that. I don't know. It's something weird like that. Something very weird like that. Yeah, we have to figure out where this thing gets populated from and how it's working. New op table. This is where it might be happening. And I think there's probably like a special case for virtual tables or something somewhere in here. Or I thought there was anyway. Wait, opt virtual table. Yeah, see, I think it calculate the stable ID. See the comment for opt virtual table .id. I think there is something weird here. A virtual table can effectively have multiple instances with different contents. For example, blah contains info about sequences in blah, whereas db2.blah contains info about sequences in db2. These instances should have different stable IDs. Okay, so this is exactly the problem. And I think the problem is that we're looking at this ID and we should really be looking at the like underlying descriptor ID for this particular use case. What a mess. What an absolute terrible mess. But we can get around it because can we get around it? You know, how did this exactly ever work? My question is, how did this ever work? Because if this ID is getting returned in a system before my changes, okay, let's use an old version of Cockroach for this test. Explain, show, create table A. Wait, users. Oh, this is too old. I think we might need to like compile a slightly older version than the one that we're on or something. Grossness. Or we could just download a binary. Let's do that. We'll download a recent CockroachDB binary. How about that? That would be a cool thing to do. v20.1 rc1. Let's get that thing. All right. Oh my goodness, what is this? Catalina is doing its dark magic. Okay. Okay. That was a bit of an annoying tangent, but the point is, let's run this thing and see what... Oh my lord. Cannot be opened because the developer cannot be verified? Are you serious? What are you supposed to do then? Catalina, you've destroyed our lives. You've destroyed our lives. How the heck? You have to hit the question mark. No way, dude. No way. Cockroach is blocked because it's... But... What? Do you have to do that every time? Or is it gonna remember? Okay, it remembers. Jeez, that's awful. That is awful. Well, this did not at all answer my question. Not even a little bit. So I don't even know what to say. I think maybe, am I the one who added this? Is it my fault? No. Apple hasn't signed the binary. Oh man, that's just a mess. Apple signing binaries, like, honestly, who cares about Apple signing the binary? That's wild. Sugjur, thank you for the follow. I appreciate it. Okay. Oh, hey, there's already an API for this exact thing. Look at that. We just had to use it. So we need to use the Postgres descriptor ID for this. And I think that will probably fix the problem. Okay, let's run our test again. Let's run our test again. And hopefully we will see some better results this time. And I think, okay, so just to back up, what just happened? Why did it matter? The reason is that it's these virtual schemas. If you ask for the tables in your database using one of these special tables, PG class, it's gonna have different results depending on the current context of your connection. So if you're connected to a database A, it's gonna give you just the tables from database A, even though it looks like the same table. And if you're connected to database B, it's gonna give you just the tables from database B, even though it looks like, oh my gosh, yes, look at those tests, beautiful tests passing. Single tear drips from my face. A single tear drips from my face. Like this, single tear. But anyway, the point is that the optimizer, to make sure that it's not like caching the wrong stuff, right? Because the optimizer is pretty smart. It's going to cache a plan. If you do one plan, rather than have to remake it, it's going to remember it. And it's going to remember it based on the IDs of all the things that it's touching. And if the IDs change, it's going to have to recompile it. And so the point is that since these tables are going to return different things depending on their context, you have to give them different IDs, or else the optimizer will get confused. So that's why we had to use a different API. And this API exists exactly for the purposes of this same thing that we're talking about, which is trying to grab the secret underlying descriptor ID, which is what we want to do here. Anyway, okay, blah, blah, blah. Blah, 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 blah. What other tests can we run? I think that information schema would be a good test to run because it has a bunch of virtual tables. It seems to pass. What about our CRDB internal? You know, here's another thing I want to do. I ran all of the tests on CI a little while ago. Oh, this one's failing though, so let's fix that up first. So the failure is that we added a column and removed, okay, this is fine. We just have to, this is an expected failure. So we just have to edit our tests to reflect reality. test flags equals rewrite. This is my favorite flag. Just wipe away all the tests and replace them with what's what. Totally safe. Totally safe. Okay, what is going on? Where's our diff? I have a crap ton of stuff that's different right now. Let's just diff this file that we just rewrote though. Okay, great. So it only has this little change. So what we wanted, I think what I want to do now is kind of start cobbling some of this stuff into commits to make my life a little bit simpler. So I know that this change, oops, oh gosh, that was the wrong paste. I want to add this guy. I know that I already have a commit for this. So I'm going to fix up just this file onto this commit called SQL show create table takes advantage of virtual index. So that's actually just the last commit, so I could just amend it. But I won't, because I already used fix up. See ya, Rohan. Thanks for dropping. Bye. Appreciate it. Talk to you later. What else do we have? We have a couple of new little things that I'll make commits for, like this descriptor table aliasing business. I think this is kind of a nice change. It's gonna make debugging things a little bit simpler. I'm gonna add this, but I'm gonna probably not commit it as part of this PR. So I'll just quickly make a commit for that as well. Git add, I guess it's constants and printers, so that's 2 and 3. I'll say keys, add pretty print alias for descriptor table. Queries to the descriptor table are pretty common, so it's nice to give them a pretty printed alias so that when looking through trace data, one can tell when the descriptor table is being accessed versus as opposed to just another user table that happens to have the right ID. Release note. Release note. What category of release is this? Oof, I don't even know. This is like a general change. It's like a tracing change. I think I might get in trouble for this, but whatever. Tracing change. Traces that contain accesses to the descriptor table will now have a pretty alias for those accesses. Malformed release note entry. No such thing as a tracing change. I guess I'll make it a general change.
Yeah.
Okay. So let's see. This top thing is completely random too. I'm not going to commit that. That was just a little experiment I did for somebody else. Oh, this we have to fix up. This is not correct anymore. So this is about, oh yeah, you know, I think this is something that we still also have to fix, which is that we can do a constraint on one of these guys and it'll push down. But if it's not an equality constraint, like the behavior is sort of wrong. Wait, not descriptor, but pg catalog dot pg class where OID is greater than 5. I think this won't really work right now. And the reason for this is that we just programmed it wrong. So let's fix it. Let us fix it. I think we even have a special case for it, which is that this guy right here. If the span doesn't have a single key, no hope. We can't deal with range scans and virtual scans yet. range scans on virtual indexes yet. And what we want to do here is we actually want to we basically want to set this variable here. And I think what's happening right now is that we don't even manage to get in here for some reason. If constrained scan. I thought this would work, to be honest. I thought this would work. Oh, I see. Oh, I see. This is gonna take a little bit more surgery to fix. The problem is that this little filter that we've created, this is our dynamic virtual row filter machine thing that happens. This gets run on every single row addition from the virtual table. And the problem is that we can't just quit here because we actually have to determine whether or not the datum is going to satisfy this constraint. You know, that's just so annoying to have to deal with this. It's just so annoying. It really would be better if we could just detect it ahead of time. Like in this thing that actually generates the constraint scans in the first place. Wouldn't it just be so much easier if we could just not push it down into the virtual table if it was a range scan? But somebody told me not to do that, so I guess I shouldn't be tempted. I guess it's actually not that bad. So here's what we do. Has single key is true if these things. And I think that what we would want to do is if there is a start and an end, then what we can do is just do two comparisons and match the filter if it's in between. I guess that's not really that bad. I should just stop complaining and do it. So I think what we want to do is we want to say if datum to filter dot compare p dot eval context. So we're going to compare to the start key. We're going to, let's see, how do we say this? Want to make sure that the datum is not less than the start key and not greater than the end key. I think that would do it. And if it's not, yeah. We might have to check their inclusivity too. Is that a thing? Start key is included or excluded. Yeah, we do have to do that. Okay. So we'll say start comparison is equal to span dot start key dot value 0 dot compare p dot eval context. Wait, let's just grab this whole thing. Start comp is equal to this whole thing. Okay. And now, I think what we want to do is we want to say, we'll start with match filter is equal to false, which is already true, I guess, at this point. Okay, we'll have var matched start bool and matched end bool. They both start out as false. If span dot start key, start boundary, that's what we want, right? Whether the start key is included or excluded. This can be included or excluded. If span.start boundary is equal to included. Span included? No, what is it? What is the type of this thing anyway? Include boundary, exclude boundary. Include boundary. We sort of want this comparison to be different. What's wrong with this? What's wrong with this? Oh, I see. It's because we named something constraint. But there's also a package called constraint. So I guess we need to also change the name of constraint. Okay, so let's rename this to be IDX constraint. Okay. So if the start boundary is equal to include, we'll say matched start is equal to start comp is less than or equal to 0. Is that right? Or do we want greater than or equal to 0? I think we want... We want this to match if the datum to filter is either equal to or greater than the start key of the span. And this returns -1 if the receiver is less than the other. So the receiver is this. Yeah, so we want greater or equal to 0. Otherwise, match start is equal to start comp is equal to 0. Is this really the nicest way to do things? I have no idea. If, then we do the same thing for the end. The end key. Let's see, I guess we sort of want to avoid looking at the end key at all if it's identical to the start key. So what we want to do is say if span.has single key. Well, let's see. If the span does have a single key, then I think what that means is that the start boundary will be include. So we've already gone through this case. And so I think see, what's kind of tricky about this is that you want to, I can't figure out whether you want to be disproving that it matches or proving that it matches. So whether you want to start with it is matching or whether you want to start that it's not matching. I think if we start with it, if we're trying to disprove that it's matching, I think that's kind of where we want to be. Well, let's try to write this out in a comment. So match is true if start key is if datum is greater than or equal to start key and datum is less than or equal to end key. So if we start with this, and we figured this out at this point already with matched start. So yeah, I guess we can say var matched start equals false. So match start equals false. Matched end is equal to true. And we'll say assume end matches matched. No. Here, we'll just have this condition down here. If span has a single key, then we can say match end is equal to true. And otherwise, we have to check the end key. I don't know. I mean, I think this is kind of disgusting, but that's fine. End boundary is equal to include boundary. Then we say matched end is equal to end comp datum to filter.compare stand.end key. If span.end boundary is equal to include, then matched end is equal to end comp is less than or equal to 0. Otherwise, this should be greater, not equal. Otherwise, let's see. Does this make any sense? Does this make any sense? If it's a single key, then over here we would have gotten include. Yeah, this does not make sense. This is surprisingly tricky. Maybe we just want one case for has single key and another case for not. I think that would actually simplify things quite a bit. So let's try that out. We'll say if it's got a single key, then we're just gonna do this one comparison. I think we have to do this no matter what. So if it's got a single key, then matched filter is equal to start comp is equal to 0. Great, simple, done. Otherwise, we do this way more complicated thing. Otherwise, we do this way more complicated thing. So we'll say, actually, we'll just go like this. If start comp is equal to 0, we break. No. We do need to set match filter no matter what. So we'll say match filter is equal to start comp if match filter break. How about that? Okay. Otherwise, we go to our hard mode case. So if it's include, we look at greater than or equal to 0. Otherwise, it's greater than 0. And then we do our end comp. Okay. We say it matches if the datum to filter is less than or equal to 0 comparison-wise with the end key. If it's include, if it's exclude, it has to be less than. And then we say matched filter is equal to matched start and matched end. And then we say if matched filter break. Phew, okay. Get rid of this. Truly horrific. Truly horrific. But I think that will probably fix what's going on. Let's find out. Let's find out. This should fail, I'm hoping. All right. All right. Always the most exciting kind of thing. Just completely explodes. So why would that happen, huh? $396. Problem is that the value of the end key did not have any. Ah, so that can happen too, huh? Wow, okay. So either of these boundaries could also not exist. That's another really fun detail here. Wow, okay. Okay, that's fine. We're gonna be good, gonna be fine. So we'll move this in here, call this comp. We'll just say if, yeah, we'll say match filter. We'll just inline this baby. Whoops. There we go. Okay, now in the hard case, we have to do something even harder. This was also wrong, so glad to catch that. What's harder is that we have to, before we even make these comparison filters, we have to check whether they exist or not, something like that. So we have to say span dot how would I check to see whether it has any values? Start.isEmpty. Oh, I see. Okay, so we can say matched start is equal to not span.start key.isEmpty. If it's empty, we always have matched the start, and likewise for matched end. Span.endKey.isEmpty. Okay. Okay. Then we say if not matched start, or what would we want to say here? Let's see. Man, this is really, there's so many cases. I wonder if, wish there was like a really nice, concise way to do this. It's pretty annoying. So many cases. Okay, well, what would happen if we just wrote it in the dumbest way possible? Let's start with that. If span.startKey.isEmpty, if this is the case, then matched start is equal to true. Otherwise, then we actually get into this business of checking things. So start comp is equal to this thing. Start key. Okay. If span.endKey is empty, then matched end is equal to true. Otherwise, okay, I think this will do it, but it is certainly gross. We can go back var matched start matched and bool. Okay, okay, run these tests again. Yay! Okay, this is exactly what I was hoping. It just meant that we had accidentally encoded the wrong thing into this test. We were checking, give me all the tables whose table name starts with something greater than t. And before we were returning nothing because the thing was wrong. And now we have something because the range scan is correct. So let's rewrite these tests. And I think at this point I might be ready to call it, assuming that that all sort of looks good to me. Because basically all I've got left to do at this point is package these things up into commits. And I think that's kind of boring to watch. So let's see though, why is this ordered wrong? Bit suspicious. Bit suspicious. That's okay. I mean, we're making some progress. Let's see. Let's take a look at this. Let's take a look at this plan here. I'm not exactly sure why it would be returning. It seems to be doing the opposite of ordering these things. It's ordering by 1,3 and it's giving us back something that's ordered by 1,3 descending because XYZ is coming first and ABC is coming second. So that seems quite wrong. Pop open our demo shell. Try to debug it. I think this is going to be probably my last act on this stream. Okay, let's see. Create database, other DB. Use other DB. No. Yes, one would want to use other DB. Oh, did I just? Thank you. Oh, wow. I was like, I think I'm just getting tired. I'm like getting confused about why basic stuff doesn't work here. Okay, that was helpful. Thank you. Create table T, a int. Okay, use our default DB and then let us check this guy again. Yeah, see, this is really quite wrong. It is appearing to be sorting things not at all, which is quite concerning. I think I know what I did here. It's that inside of, we're building these special things, because remember, I don't know if you remember, but back in the beginning of the stream, I was talking about how these virtual indexes, they don't provide ordering necessarily, so we have to beat them into shape. we have to provide our own ordering. We do that in here. Is it in here? Where is it? Create virtual, construct virtual table scan. Yeah. So over here is where we say we need to make a sorting operator on top of these constraints, because otherwise we won't really provide any ordering. This required ordering was the thing that I thought that we could use to produce the ordering, and I don't know if this is really working right. I think let's do a quick test here. If I did select star from, let's actually explain this guy too. That could be good. See, it looks like this ordering is sort of just getting ignored. That's what I see happening. If I do order by table schema, I also don't see a filter or a sort. It's a bit mysterious. I must have done something pretty dumb. But I don't know what it would be. Let's look at what happens when we do explain opt on this. So ordering by table type gives us a sort, which is nice. Ordering by version gives us a sort, which is nice. But if we order by table schema, for some reason, it doesn't want to give us a sort. And I wonder if it's because I did something dumb when defining this. Yeah, so I've put this index on table name. And because of that, it assumes that it's sorted by table name. Thing is, it's really only supposed to do any of this stuff if I add a constraint, and I did add a constraint, I see. So I think if I got rid of all this, it would be fine. And the problem is actually that I've made this constraint checker thingy a little bit too restrictive. And I think over here, I just have to, no, I think it's the opposite. Now I'm confused again, because I think that this is it's not restrictive. It says if I have any constraints at all, then I have to make a sort, and the sort has to be on this required ordering. So what's the deal? What is the deal? So if I said where table schema greater than foo, that still has a filter. And what if I did where table name is greater than foo? Oh wait, I have to have order on table name. Yeah, this is sort of this exact thing that I'm talking about. But it's got a sort. So what was the problematic example again? It's if I have two constraints. I'm constraining table catalog and table schema. That's when the thing gets really unhappy. It doesn't give me any kind of sort node. And let's, as an example, see what happens if I just do a single filter. Is that still going to be broken? It's only when I have two filters. And what if I get rid of this first filter? Is it still broken then too? Yes. Okay. So where did I add a thing that checks the width of this constraint? I know I did it somewhere. And I think in this case it would be no, I don't really understand this, because these two things really shouldn't be turning into constraints that the virtual table sees at all. That's the thing that I'm confused about. In fact, they don't, because when we see a constraint that we know we can process, there's a line here. This is an example of that. This is where the filter has been transformed into constraint. This is something different. I wonder, let's see, if I were to run this on before my modifications, do I still have the same issue? Do I still have the same issue if I run this before my modifications? I'm guessing that no. I'm guessing that things will work fine. But if they didn't, that would be, No, it's sort of the same problem. So I think that's pretty weird. So wait a minute. If I create table B, then I create another table T, and I do this big thing. Order by table schema. Why the heck wouldn't it actually put a sort? That doesn't make any sense. It does put a sort. Oh, I see. Okay, I've gotten really confused. The reason is that if you have a constant constraint on one of these columns, then sorting it doesn't do anything, so you can just ignore it. Okay, well that was a big tangent rabbit hole, and not the problem that I was trying to fix. Okay, so the problem that I was trying to fix is that in this case, order by 1, 3? What is this even saying? Order by table catalog, table name. Okay, so we don't need this order by 1 thing because we've constrained 1. That's kind of the key takeaway why I'm super confused. Create database, use other DB, create table T, use default DB. Okay, let's run this again. Let's run this again. Where is it? Where are you at, friendo? This thing. Now, if I got rid of order by 1, and I just had order by 3, what the heck is order by 3 just the same as the third column? Is that what it means? If I say order by table name, is that the same thing? It does seem to be the same thing. Well, this still seems quite wrong. Seems quite wrong. Seems quite wrong. I think, oops, table name. Oh, I think I see the problem. The problem is that there's no constraint. and that we have an ordering, and we're using this special index because, oh, I see. Huh. And then since we have no constraint, it thinks that it's not going to use any index. Okay, so let's check this case then. The case that we're checking is that we've passed no constraint here, and yet we're still using one of these special indexes. That is so weird. Is there actually even a case for that? If constrained scan. Yeah, okay. So over here, the thing is that order by 3 is order by third sex. Okay, somebody is telling me on a side channel. Brilliant. Thank you to Radu. So here's the thing. When we're constructing this virtual scan, if the optimizer thinks that we want to be using this index and we have no constraint, which can happen because of ordering, I didn't consider that, then we have to, yeah, so it's like if index constraint is not equal to, is just the wrong condition here. The correct condition is probably like, we have a non-empty index or something, or like this index is not the default index. Or the index provides ordering. I don't even know. I don't even know how you can exactly like specify this. I guess for now we can just sort of hack it, and we can say, oops. We can say if index.id is not equal to 0, basically. So if we're not using the virtual table's default index, it means that we might be claiming to provide an ordering that we're not actually going to provide. This might happen if we've actually pushed a constraint into a virtual index, or it might, or if the prefix of the index, that prefix of the virtual index happens to match the desired ordering of the overall query. In these cases, we have to actively sort the results according to the required ordering using a sort node. Okay. All right. Let us run our test cases, not with rewrite. Just check required ordering. Required ordering is the ordering that is needed from the scan. Conveniently only set if we actually need it. Okay. That does seem a lot simpler. So required ordering. How is this? Does it have an emptiness? How do I check if it's empty? No ordering. Okay, so I could say if column ordering, I guess I could just say if len column ordering is 0, or let's try that out. If required ordering is not equal to no ordering. This isn't gonna work though, because you can't really compare slices like this, right? We'll do this. If length of required ordering is not equal to 0. Okay, What happened here? ID. Okay, yeah. I think that was just a flawed methodology. Let's get rid of this flawed methodology and try again. So now I guess the idea, that's actually quite nice. Okay, so we can revise our comment too. So required ordering will be set if the optimizer expects that the output of the exec node that we're returning will actually have a legitimate ordering. Virtual indexes never provide a legitimate ordering. Legitimate ordering. So we have to make sure to sort if we're expected, if we have a required ordering, if we have a required ordering. Okay, nice. Okay, this is exactly perfect because this is failing, but what we had encoded was wrong in the first place. So we can just rewrite, and then I think we'll be good at that point. Now, if only it didn't take so long to compile and run these tests, that would be great. That would be really great. All right, so what's our diff looking like now? It should be basically 0, except for that one thing at the top where we've added an index. And it is. That is awesome. And we can get rid of this how to construct this filter business because we sort of constructed the filter already. Sort of. I do still think that this might be better, but maybe we can do it later. For now, we've done a different way. And let's see. So what test did we end up writing again? I think we added a new one called I think we added a new one over here, maybe? No, where was it? It was over here. Virtual, maybe? I think it's this one. So in the exec builder tests, we can actually check that the plan is something that we like. I guess these tests are actually gonna be a little bit weirder though, because we need to kind of verify all of these actual output results. Like we need to make sure that this range scan stuff is working properly. So I guess, oh, you know what we could test here is we could test that sort logic that we just added. That would be a good thing to test. So, oops, that didn't. Test data, virtual, there it is. Make sure that if we need an ordering on one of the virtual indexes. Oh, and by the way, we should probably also add the virtual index name to this source row thing. That would be good. And I think we can do that over here. Right now, you can't really tell. You can see that it's coming from this thing called tables. But first of all, that's not even, I mean, you sort of want the whole thing, whatever. More importantly, we need the name of the virtual index though. Source. Okay, so it's got a name. Ooh, but we don't write down the name of the index anywhere. That's kind of unfortunate. It's because this delayed node business is just sketchy. That's the problem. Whatever. We can come back to this later. So we'll just say, make sure that if we need it ordering on one of the virtual indexes, we provide it using a sort node, even though the optimizer expects the virtual index to provide it naturally. Okay, so we'll do the same thing, but then we'll also order by table name. And we can do sort of greater than blah. And this should, well, let's see what happens with this. So I'm expecting that this constraint will now become a range constraint. And I'm also expecting that we'll get a sort node above it. We'll see if that actually happens. Okay. Did it work? Did it work? Yes, it did work. That's great. Let's also make sure that, because I had this fear. Well, let's see. I was going to say, I guess, because I know for sure that if you have a composite virtual index, things will not work properly. But I think we have things in place to prevent that pretty low down. Because I think that when we actually create the index in the first place, so that's called, what was that? It was like make info or something? Info, virtual info, something, virtual. I always forget the name of this method. Get virtual table desk? No. Where the heck is this thing called? Init virtual table desk, that's what it's called. So I think over here we definitely make sure that indexes only have one. Maybe we don't make sure about that. That would be quite problematic. Actually, let's just do a quite simple thing. Let's make sure that if we have two constraints, one of them that matches and one of them doesn't, things sort of work properly. I think this is going to be a gimme because the optimizer will take care of this. But let's just make sure. And what else is in information schema.tables? Information schema.tables. Tables table? Table type, table name, table type. Okay, so we'll do where table name was blah and table type is equal to foo. And this is going to be just make sure that we properly push down just part of a composite index, composite filter of a filter on two columns where only one of them, only one of them is satisfied by the virtual index. I think this is maybe sort of a duplicate test, but I don't know. It's good to have in there. I think we should add like a little thing that just makes sure that nobody accidentally is going to, okay, this is great. Nobody's actually going to make a composite index because that would really break a lot of stuff. It should be very simple. It's back into this init virtual table desk. We just want to look for index defs. Where are we checking for those? So for each I see. So we just actually don't even validate this right now. So it's very simple. We just have to say if mute desk dot index, or if idx dot column IDs, the length of this thing is greater than 1. We'll just panic and say, we don't know how to deal with virtual indexes with composite keys yet. Virtual composite indexes yet. Okay, so that'll just be a little quick check to make sure that we don't accidentally write some crappy code that doesn't work. A hapless developer. Okay. Let's see. Anything less to do here? Hey, yes, sir. How are you doing? We're working on, yeah, I tried to summarize it there. I don't know if it made that much sense, but there's this database that I work on, CockroachDB. They have virtual tables. And if you wanted to filter a virtual table, you'd have to kind of get all the data from the virtual table first and then filter it afterwards. And what I wanted to do is make sure that if you had a filter on something that we could do better on, you could just pull out the data that matches the filter rather than having to pull out all the data and filter row by row afterwards. I don't know if that was comprehensible. I think the issue gives a decent summary of it though. Yeah, all right, so I don't know. I think I might be kind of wrapping up, to be perfectly honest. I think we have a pretty decent idea that this thing should work. Let's do a quick demo just in the terminal to make sure. Even though I have tests for this, just because maybe it'll be fun. We'll create a table. We'll call it T. And if I look in my descriptors table, which is the thing that actually has this data like we were doing in the very beginning. And you know, I even have a visual for this. Hold on a second. If I unhide this little guy, I was drawing Michelangelo, but we can stop drawing Michelangelo and go back to the really useful visual here. If you can sort of see this, and I don't know if you're really going to be able to see this. So, you know, I'm going to go to my other view here real quick. Yes. So the idea is I've got this table. Man, I drew way too much crap on this, so it's probably impossible to see. It's probably impossible to see. But the idea is that if you look right down here, you can see that there's this table, descriptors table. Descriptors has data for each of the tables in the system. It's sort of like a metadata table. And if you're smart, you know that you can scan just the part that you want. So if I had table 52, that's what my example is having here. And I think even here, this table T that I just made in this view should have ID 52. Let's check, select T reg class OID. I think this will say 52. Yeah. So the point is that if I said something like select star from system.descriptor, where ID is equal to 52, it's going to scan just this little part that I've tried to draw here on the whiteboard. It's just going to jump just to that part of the table. But there's some other tables that read system.descriptor, and they used to do it in a really dumb way. And this PG class is a good example. So if I said select star from PG class, where OID is equal to 52, before what this was going to do, it was actually going to have to to scan this whole table here that I just outlined in yellow. So if I had 2,000 descriptors in there, I would have to scan all of them. You don't see the ID. Yeah, I know. I've hidden it temporarily. I would have to scan all this crap, and it would be really slow. So what I've done in this stream, partially, I did a little bit before the stream too. I made it so that if you select from one of these virtual tables, and you could potentially use the index on descriptors, it's instead just going to reach right into this, scan just 52. That's the dream. And I think what we do now to test that is run this query. And I'll do it over here, back in the IDE again. Zoom this over here. Get rid of that Michelangelo face that is really distracting. I think what this is going to do is just scan the part of the descriptors table that we care about. You can see that it's got this constraint. It's sort of meaningless until I prove it. I'll prove it with auto trace like I did earlier. Set auto trace equals kv on comma kv. And if I run this for real, we should just see a... Okay, so maybe auto trace doesn't quite work with these because it's happening under the hood somewhere else. That's sort of sad. I can't prove it. It's a bit suspicious. But it does return the right result. So I wonder why the tracing doesn't work for this. It seems a little bit messed up. See, I can't just take words. I can't just say take my word for it. I just can't do that. That would be whack, because I don't know if I even take my own word for it. I think it must mean that somebody's passing the wrong context somewhere, so the trace doesn't get filled out properly. That's so annoying. That's so annoying. But I think I know where it could be happening from. Let's just quickly take a look at this and see. It could be happening in this thing called get make all relations virtual table. This is the thing that really should be getting tracing, and it isn't. The context is coming from this populate. And who calls this populate? Get plan info does. And what context is this? This is the constructor's context. And this constructor gets the context of whatever this construct. Oh my gosh, it's just like endless. It's just endless. But I don't know. I mean, I think this should honestly work, so I'm slightly confused. The tracing doesn't work, all right? It's not that big of a deal. It's kind of a big deal, but it's not that big of a deal. Why would not the tracing work? Does this thing get some kind of weird context that doesn't have all the stuff in it or something? Man, that's annoying. It's quite annoying. But let's, okay. How about just for the purposes of both debugging this for a little bit and also proving to myself that things are still working, we're just gonna print something out real quick when we actually do this table lookup, which is the whole point. This is the special moment. If we get here, we know we're doing our fancier filtering. Okay, so we'll say printing table, or rather looking up table, passing this ID. I also kind of want to print out, like, I don't know. I want to make a little log line thing just to see how come we're not log.event f. I think this is going to print out something into the logs context. Hello. How about that? I think this would print out into the trace if we did get here. So let's quickly try that out. Let us see. Let us see if that's going to work. You think it's going to work? I don't really know. The tracing is really important. It's really, really, really important. because without it, it's hard to kind of figure out what the heck is going on when you do stuff. Both for people who use the database and for people who work on the database. Both of them. It's both important for both. All right, so let's try this one more time. We're gonna make our table. We're gonna select from PG class. Okay, so we're getting the right. Two good things happened. We got the right output and we got our little print line. So we know, we know for sure that we're not completely deceived. The question is this auto tracing stuff, or is the tracing stuff working? If I turn on my tracing and I run, I do get this hello. I do get this hello. I just don't, for some reason, get. Oh, I think I know what it is. It's probably just that this little method here doesn't actually have to do any, or it doesn't have any, it doesn't hook into KV tracing. It doesn't hook into KV tracing because this thing, it's sort of reaching in and it's doing things in a raw kind of fashion. So basically, it's all good. It's basically all good, and we see this planner getting table on table ID 52 thing. So this is what we can use to prove ourselves that things are working. All right. Well, I think I'm gonna call it with that. All right. We have hopefully a pretty satisfying story to this stream, because the point is that this operation, simple as it may seem, is doing something much smarter than it used to before. It's reaching right into descriptors. It's picking out just one row, and it's not picking out all the rows and filtering. So yeah, I feel satisfied, okay? I feel satisfied. Did you guys understand any of that? It's my question to you, the viewer. I don't know who's been watching and whether they understood, but hopefully it was enjoyable, even if you didn't quite get it. And if you did quite get it, that's fantastic. Make sure to follow on Twitch if you haven't done it already. Maybe some of you don't even have Twitch accounts. And let me tell you, you should get one of those. You should follow this account because it's going to be helpful for me. I do this every Friday. So if you liked it, please tune back in. I've been doing 3 p.m. EST. Probably going to keep that up. So tune back in. Follow me on Twitter too. It's in my bio. And also, look, last thing. I'm really just streaming stuff that I feel like doing, but if I had any requests, if I had stuff that you guys wanted to learn about, I'd be more than happy to check it out. So let me know. Send me a message on Twitter, send me a message on YouTube, and I'll try to answer your questions. Let's make it interactive. Let's make it fun. Cool. Okay, so with that, I'm going to sign off. Thank you all for watching, and have a fantastic day, fantastic weekend. Peace.